All right. So let's continue where we are. The final exam would be a mixed type questions, okay? Multiple choice, short answer, filling in the blank. Okay. Any other questions?
Do you expect us to read the textbook and the modules, or just the modules online?
Excellent question. You are expected to read both online modules on D2L and e-textbook. Expect, especially the examples in the textbook.
Okay, thank you so much.
If you don't have time, read all the textbook content. Treat examples as exercise. Try to figure out by yourself if you're stuck. The example have detailed step-by-step solution.
All right, thank you so much.
You're welcome. I love your question. Any other questions?
Also, when is each MyStatLab module due for each week?
The first due date is, I email you, give me 1 second, I can pull this out. See, I email you this one, okay? Oh, the first due date, see, can you see it? May the 15th. Each Friday midnight, you have one module due. Module 1 is due May 15th, and module 2 due May 22nd, etc. Last module, module 11 due July 24th. Our final exam is on July 25th. Okay, the due date is on my lab. Thank you for your question.
Thank you so much.
Any other questions?
Are the quizzes timed?
Thank you. The question was, are the quizzes timed? Yes, the quizzes are timed, maybe 1 hour or 1 hour and a half. I will, 1 week before the due date of the quiz will be released. So I plan to release quiz next week because the first quiz is due week 3.
And how many questions?
Quiz 1, about 10 questions, around 10 questions. Okay.
Multiple choice?
There is 1 short answer questions. The rest are multiple choice.
Do we have only 1 attempt?
Oh, for the quiz, yes, you have 1 attempt. But for my lab, each question, you have 5 attempts. Okay. Any other questions? All right, so that is the due date for quiz and my lab. Okay. So today, so that concludes introduction part, and I also answered some questions. Please continue ask questions while I am talking. Okay, stop me anytime. So I will highlight what you are going to learn in module 1 and in module 2. Okay, in online module 1, it is a review of basic statistics you have learned in CQMS202. So I will emphasize on central limit theorem. Okay, central limit theorem said the mean of all sample means equal to population mean. So mu is population mean, mu x is the sampling mean, they are equal. And the second item in central limit theorem said standard deviation of sample mean equal to this sigma x bar represents standard deviation of sample mean equal to population mean, population standard deviation sigma divided by square root of n. Okay, so central limit theorem is very important, CLT. Refer 2 formula. One is mu x equal to mu. The other is sigma x bar equal to sigma divided by square root of n. Okay, and sigma divided by square root of n is called sampling error. You have this term in your MyLab. Okay, some students ask, what is the sampling error? Standard deviation divided by square root of sample size. And another question I already got commonly asked is, how do I know it is normal distribution? Okay, it is normal when you have large sample. How large? How do you know it is large sample? When sample size greater than 30, you can assume it is large sample. Okay, so this is online module. Okay, commonly asked questions about this one. Any questions? All right, and in this chapter, so in this module, I will combine module 1 and module 2 because module 1 is already passed. The past 1 week is module week, the coming week is module 2, okay? In these 2 modules, you need to know all the 4 sections in chapter 10, okay? Section 1 to 4. Section 1 is confidence interval estimate. I will pull out the PowerPoint slide here so you know. See, section 1 is confidence interval estimate for population mean when you know population standard deviation. When you know, that is section 1. And section 2 is confidence interval estimate for population mean when you do not know population standard deviation. When you say sigma, it must refer to population. When you say S, that means sample standard deviation. Okay, and section 3 is about confidence interval estimate for population proportion. And section 4 is how do you calculate sample size. Okay, so those are module 1 and module 2 content right here. Okay, so now I'm going to give you a concrete example for section 1. And this example is a question from several students, not just one student. Several students asked this question from the past semesters, okay? Can anyone see my see this question? Question 5 here. Can anyone see the question?
Yes, I can.
Okay, thank you for confirm. So the question is, the quality control manager of light bulb factory needs to estimate the mean life of a large shipment of light bulbs. The standard deviation is 98 hours. Now, students have question. How do I know this standard deviation is population standard deviation or sample standard deviation? So far, you do not have any sample data. Just stop here. Just up to here, you don't have any sample data. You don't have any indication this is sample standard deviation. So this is population standard deviation sigma, 98. Okay. And the next sentence, you have a random sample of 49. Okay, so this is sample size 49. A random sample of 49 items indicated a sample mean is 390 hours. Sample mean, okay? So now question asks you, construct 99% confidence interval estimate for population mean. That is the question. And this question belongs to chapter 10, section 1, because you know population standard deviation sigma 98. Okay, any questions? Okay, once you understand what is asked, I will introduce 2 different methods. Method 1, use the formula. Okay, so the formula said, the population mean mu smaller equal to sample mean x bar is 390, okay, plus critical value, Z half alpha, okay, multiplied by population standard deviation over square root of sample size n, okay, and the population mean mu greater or equal to sample mean x bar minus Z half alpha, multiplied by standard deviation over sample square root of sample size. This is method 1. You know every number. X bar is 390, sigma 98, n is 49. The only thing you are concerned is this Z half alpha. You can get Z half alpha from here, 99%. If you are given 99%, you can figure out Z half alpha. Okay, I will give you the picture here. What does 99% mean? This is the bell-shaped symmetry, okay, normal distribution. 99% means the area under this bell-shaped curve is 99%. The area under this bell-shaped curve is 99%. Once you are given this area, there are 2 points are fixed. This is 1 point, is Z half alpha. And there is another point, negative Z half alpha. Okay, how do I find those 2 points? You use a calculator, okay? The calculator is, make sure you are at the start STAT mode. Okay. To find out what is Z half alpha given 99%, you do this. Okay, once you are at the start mode, you do F5 represent distribution, F5 represent distribution, and then you do F1. If you have calculator with you, I strongly suggest you follow my steps now. Okay, pull out your calculator. Make sure it is start mode. Press F5 button, distribution, then F1 normal, and then press F3 button. Okay. After that, you have inverse normal, data variable, tail, select center. So you type in under tail 0.99. So central area 99% is the same as 0.99. Okay, area 0.99. Sigma, you type in sigma is 1 because this is a standard normal distribution. Sigma is always 1, mu is always 0. Okay, sigma is 1, mu is 0. And then you press EXEK and you will get negative 2.575, positive 2.575. So this Z half alpha equal to 2.575. And this negative Z half alpha negative 2.575. This is a very basic step in CQMS202. Make sure you are 100% comfortable. Given any percentage, 95%, 92%, 87%, can you find Z half alpha? Yes, you follow this step, you can find Z half alpha. Okay, so any questions?
What did you put in for your mu and your data?
Thank you. Data variable, tail central, area, typing 0.99, sigma is 1, mu is 0. Okay, put sigma is
Thank
1, mu is 0.
Thank you.
You should get 2.575. Thank you for asking. Any other questions? Okay. So this is see you this formula. You have every number you know, you can figure out. This is method 1, use the formula. Okay, so next, I'm going to introduce calculator method to find out what is 99% confidence interval estimate. 99% confidence interval estimate for population mean, calculator method, okay? So on your calculator, the question asks for interval, so make sure it is start statistic mode. And then you press F4 button, interval, F4 button, interval. And this, after interval, you have 2 choices, Z and T. Again, this is commonly asked question. Do I use Z? Do I use T? You use Z when population standard deviation is given. See, population standard deviation is 98. Population standard deviation. So you use Z, okay? So F1 button. After F4, you press F1. And this is 1 sample. So you press F1 again, 1S. Okay. After that, on your computer, you have 1 sample Z interval, data variable, C level means confidence level. It is given 99%. You type in 0.99. Okay. Next, sigma. This time, sigma is 98. Population standard deviation is 98. Okay. X bar, sample mean is 390. So you type in 390. Sample mean. N is sample size, 49. 49 is sample size, you type in 49. And you press EXE, you get 2 numbers. Left, 353.94, right, 426.06. So those are the confidence interval. Okay, what does mean 353, that is left, means the population mean is any number between 353 and 426. Okay, any questions? So that is the core concept in chapter 10, section 1. Confidence interval estimate for population mean when population standard deviation is given. Okay, any questions? Section 2. Section 2 is about confidence interval estimate for population mean when population standard deviation is not given. When population standard deviation is not given, you do not use Z, you use T. Okay, so first we are going to introduce T table or student table. This table here. Okay, so this table said T distribution is also similar to bell-shaped, but it's not that perfect bell-shaped. Okay, you can assume it is bell-shaped. Okay, there is a little right tail. Did you see on this graph? This little tail, the area we call alpha. This little right tail we call alpha. Okay, once you have this little area, there is a point. This point we call T, and this T is the critical value. Okay, so suppose commonly used alpha 0.05. Suppose this is 0.05. Okay, suppose it is 0.05, and this is one-tailed situation, and you have a sample size, for example, sample size equal to 20. Okay, so I repeat the question. Given the right tail area 0.05, alpha equal to 0.05, sample size 20. Question, what is the point for this T? What is T equal to? So go to this table. Okay, go to this table. Upper tail area 0.05. See, this is upper tail area 0.05. And then locate degree of freedom. In T table, it is sample size -1 is degree of freedom. So I have sample size 20, -1 equal to 19. So I locate 19. The intersection part of 19 with 0.05, I get this number, 1.7291. That is this point T. T equal to 1.7291. Any questions? How do you find critical value T based on alpha and sample size? So this is method 1 based on table. Method 2, use our Casio calculator, okay? So for calculator, you press F5 distribution, okay, F5 distribution, and then F2 T distribution. After that, F3 inverse T, okay? And then area refer to this right tail area. You type in 0.05 is the area. Degree of freedom, you type in 19. And then you press EXEK. Can anyone share your result? What did you get from your calculator after you did all of the steps?
I got a 1.729, same as the chart.
Terrific. Thank you for sharing.
I also got
So I repeat the procedure, okay, in case you didn't get it, because this is extremely, extremely important. It is as important as 1 + 1 equal to 2, okay? If you don't know this, I'm so worried about you, okay? So I repeat, go to your calculator, press F5 distribution, F2 T distribution, F3 inverse T. Make sure data is variable. Data variable, area typing 0.05, df, degree of freedom 19, and then press EXE, maybe 2 times, and you get this number, 1.7291. Okay, any questions? Okay, so once we understand this, we do a little bit exercise. This exercise is some students asking this question. That's why I emphasize the Zoom session is sometimes I call it just Q&A, okay? So please ask questions. So this is the question. Can you see question 6? Determine the upper tail critical value T½ alpha in each of the following circumstances. We just do 1. If you can do 1, you can do 5, you can do 10. Okay, so let's do just 8. 1 minus alpha equal to 0.9, n equal to 15. Okay, let's just do question A. If 1 minus alpha equal to 0.9, what is alpha? Alpha equal to 1 minus 0.9. Do you agree? So alpha equal to 0.1. Any questions? Alpha equal to 0.1. Okay. The question asks you T½ alpha. So first, what is half alpha? When alpha 0.1, half alpha 0.1 divided by 2, it is 0.05. This is half alpha. Okay. And once you have half alpha, you draw a diagram. So this becomes half alpha. This is not alpha. This is half alpha. 0.05. The question is, what is this point? This point is t subscript half alpha. That is the question. What is this t half alpha? That is the question. Okay, again, 2 methods. One, go to the table. So the table is right here. Okay, so I'm going to erase all the okay. So go to this table, but apply to this situation. Half alpha 0.05. Okay, so you locate this area is half alpha. The value of half alpha 0.05. Okay, so you locate this one, upper tail area. Okay, and then degree of freedom n equal to 15. Degree of freedom equal to 15 minus 1 equal to 14. So you locate 14. So the intersection is this number, 1.7613. This is the answer. Okay. So this is a table method. Okay. Method 2, calculator method. Okay. To use calculator method, you follow F5, F2, F3. Okay. And then area, you type in 0.05. Degree of freedom, you type in 14. And then press EXE. And what, anyone want to share, what did you get? Anyone get this number?
1.7613.
Thank you so much for sharing. That's correct, 1.7613. Excellent. Okay, so we use 2 methods. And once you can do this question, you can do question B, question C, question D, question E. They are the same question, different numbers. Is that clear? Okay. And when you do this question on my lab, pay attention to requirements. Round to 4 decimal places. Okay. Read instructions carefully. So this is this question. Any questions? All right. So that is the section 2, confidence interval estimate for population mean when you use a T distribution. When you use T distribution, the formula is, in the textbook, the formula is mu. This formula is for section 2 in chapter 10. Okay, mu smaller equal to sample mean plus T half alpha. T half alpha multiplied by sample standard deviation S divided by sample size, take square root. This is the upper bound. Lower bound, sample mean X bar minus T half alpha times sample standard deviation divided by square root of sample size. So this is formula method. And what is the calculator method? To figure out what is the population mean interval, so you do F4 button, interval, and then F2 T. Finally, you do F1, 1 sample. You follow these steps, you can get the result of lower limit, upper limit. Okay, any questions? All right, so this is section 2. And section 3, chapter 10, section 3 is about confidence interval estimate for population proportion. Okay, In CQMS202, if you see the keyword proportion, you have no choice but use Z, not T. When you see the keyword proportion, you use Z, normal distribution. Do not use T. Okay. So I will give you an example. Okay. I will give you example. Suppose in this class, I have 57 students. Okay. I know out of 57 students, 30 students have part-time jobs. 30 students have part-time job. And I ask you, construct, I'll type it up, okay? Construct 99% confidence interval estimate for population proportion. That is the question. Section 3 of chapter 10, okay? Just try to increase the font size. Okay, so the question is, in a class of 57 students, I found 30 students have part-time job. The question is, construct 99% confidence interval estimate for population proportion. Okay, so again, two methods. Method 1, use formula. Method 2, use calculator. During the exam, you decide what method you want to use, okay? I don't force you to use which method. So when you use formula, the formula is P is by the way, P, introduce P. P is sample proportion. And we call this 57 is sample size. We call this X is number of objects or people having some characteristics. In this situation, this X represents number of students having part-time job. So you understand N and X, okay? P is sample proportion, X over N. Okay. So equal to 30 over 57. That is P, sample proportion. So the formula said, sample proportion minus Z half alpha, okay, times square root of sample proportion P times 1 minus P divided by N, okay. Population proportion, we use pi. Population proportion use pi. This pi is different from mathematical constant 3.1415, not that number. This is just a letter, okay? So pi, population proportion, the upper bound, sample proportion P plus Z half alpha. And square root of P times 1 minus P over sample size N. Okay. You know P is this number. You know N is 57. The only thing you are concerned is Z half alpha. Remember when you have 99%, we did this question before. When you have 99%, Z half alpha equal to, anyone can recall what is that number? We did that example, right? When you have 99%, Z half alpha 2.575. So you have every number you know, you just plug in this formula. So this is method 1, and method 2, use calculator. Okay, so you press F4, interval, F1, Z, and then F4, F1, and then F3, 1P means 1 proportion. I repeat, F4, interval F1, Z, F3, 1P, 1 proportion. Okay, after that, you are asked for C level, you type in 0.99, and you are asked for X is 30, and then you are asked for sample size N 57. Press EXE, I get 0.35, maybe 36, just 2 decimal places, okay? This is lower bound. Upper bound, I get 0.70. Okay, so that is the population proportion, anywhere between 36% to 70%. Okay, based on sample data, I conclude the whole population students having part-time job between 36% and 70%. Any questions? All right, so that is section 3, confidence interval estimate for population proportion. And section 4 in chapter 10 is about how do you figure out sample size. Okay, and this section you just need to know how to use the formula. The formula is given. Okay. So the formula is, you just need to plug in the formula. There are 2 formulas. One is sample size equal to Z half alpha squared times population standard deviation divided by margin of error, E squared. E is margin of error or sampling error. This is one formula. The other formula is Z half alpha square times population proportion P, 1 minus population proportion of pi, and then divided by E squared. E represents margin of error. So that is chapter 4 content. Make sure you go over examples on online module on D2L, go over examples on the textbook. Any questions?
Is there a way to input that on the calculator?
Yes. In calculator, you have to use normal calculation, not statistic calculation. So you go back to your calculator, press menu, and then select Run Mat, R-U-N-M-A-T. Okay, so I would actually strongly suggest use Excel. Use Excel to do the calculation, to do these calculations. For example, Z half alpha equal to 1.96 multiplied by sigma. Sigma is 3, for example. Sigma square divided by E square. E, suppose it is 2.5 square. Just suppose, and you get the answer right away. Oops, yes, I forgot the square. So anyway, you can use the Excel to do it. Okay, I will double check. So this has to be square. Okay, when you do sample size problem, always round up regardless. For example, you get 8.4. Usually you would drop 4, you would say 8. But this is the number of objects, number of people. You would say this is 9 people, 9 students. Always round up for sample size problem. Okay. Any other questions? That is the Zoom section. We have some time. It is, I just opened the floor up. You are welcome to ask any questions, okay?
By next week, we should have read up to chapter 10, point 4, right?
Yes, by the end of week 2, you should read all chapter 10, session 1, session 2, session 3, session 4. Yes.
Thank you. Thank you.
Any other questions?
Yeah, so, yeah, hello. So these, for the F4, F1, F3, does that replace the calculations that you did in Excel?
Can you say that again? Oh,
Sorry.
Section 3, the formula. Are you talking about this?
Yeah, that one, yeah.
Yeah, you can do it on Excel, definitely. But you need to do 2 calculations. This is one calculation on the left-hand side. This is another calculation on the right-hand side. You need to do 2 calculations. Yes, you can do it on Excel.
Okay, thank you. Also, will this live recording be on D2L or any?
Yes, I will post this live session on D2L, but we missed the first part. I forgot to press the record button. You may not see the beginning part. The beginning may be 5 minutes. Yeah.
Okay, that's fine. Thank you.
Yeah, I will post this on D2L.
Okay, thank you.
You're welcome. Any other questions? Because this is the first time we are doing the Zoom, next time, you know, you have plenty of time, plenty of opportunities to ask questions. Please prepare ahead of time. Write down your questions and ask during the Zoom session. Before the Zoom session, I will give you a few minutes. Okay, during the Zoom session, jump in. Okay, and then toward the end, see, we still have time to ask questions. Any other questions? So before I let you go, I just want to say students are the most important asset on campus. Without students, there would be no need for the Institute for Ryerson to exist. Thank you so much for attending this Zoom session. I hope to see you next time. You can still stay, we still have a few minutes, okay? I will just press the stop recording. Feel free to ask any questions, okay? We still have some